In the CNC machining bay, the massive gantry suddenly begins moving and sweeps directly into the active travel path. At a muddy dockside work area, an exposed rotating shaft remained active while unstable access developed around the equipment. At a South Salt Lake loading area, a powerful gust turned an ordinary trailer door into a rapidly moving hazard. In the tanker yard, the tanker suddenly begins rolling as the protected space behind it rapidly disappears. On the aft mooring deck of a vessel, a snagged mooring line suddenly released stored tension within the rope system. At a street-side spool operation, exposed rotation turns loose clothing near the motorized reel into a fast entanglement hazard. Inside a heavy fabrication area, suspended machinery shifted without warning, while the work zone below remained exposed. On a snowy roadside beneath overhead utility lines, a tensioned wire suddenly releases stored energy and snaps through the elevated work area. In a wood processing area beside a rotating log handling machine, exposed rotating components remained active as material entered the machine's draw-in path. On the rainy street, the large metal suddenly loses stability and drops out of position during movement. At an active construction yard, a concrete pump boom entered the clearance space surrounding energized overhead conductors. Inside a vehicle repair bay, a raised truck bed rests on hydraulic support. Without warning, gravity takes over. In a recycling yard, material processing equipment remained active while exposed machine movement paths operated beside the processing line. In a crowded sorting area, a forklift raised a bulky load while nearby movement paths remained directly beneath the load path. In a compact restaurant kitchen, a gas cylinder supplied fuel beneath the cooking station when accumulated gas suddenly encountered an ignition source. At a fuel transfer depot, flammable vapors accumulated around the transfer area until a single ignition source changed everything. In the hot metal processing area, the discharge vessel begins tilting when trapped energy suddenly erupts from the opening. Inside a narrow commercial kitchen, a large pot of hot liquid entered a slick floor area where stability rapidly deteriorated. At a storefront in New Taipei City, a partially open rolling shutter remained within an active closing path, while the opening stayed accessible. On top of the production line, the machine's feed path suddenly reactivates and pulls the material channel into motion. Feed systems, rollers, and transfer mechanisms store motion through rotating components, drive systems, and automated sequences. Any available motion path remains hazardous while energy sources remain connected. Inside a timber storage area, massive wooden logs suddenly shifted while the access lane remained completely exposed. The unstable timber stack created a rolling force hazard where unsecured logs could suddenly shift into nearby access paths without warning, especially during ongoing material movement and changing ground vibration conditions. In a vehicle wash area under the midday sun, energized equipment operated within a wet environment as electrical continuity developed through the work area. Electrical energy follows conductive paths created by moisture, damaged insulation, grounding defects, and energized equipment. When electrical isolation fails, unintended conductive pathways can develop throughout the surrounding environment. At an industrial facility entrance, a large sliding gate was being moved when the structure suddenly lost stability and shifted from its intended path. Sliding gates depend on tracks, rollers, guides, retaining devices, and structural support to maintain stability during movement. Any reduction in support integrity can alter the gate path and transfer the structure's weight beyond its intended travel line. High in a backyard tree, a loaded branch suddenly releases a chainsaw cutting changes the load path and support forces. Establish stable footing, secure cutting positions, and control branch loading before chainsaw work begins. Loaded limbs, cutting forces, support points, and gravity act together, and a small change in the cut can rapidly redirect the entire load path. On the busy city street, the truck-mounted crane suddenly shifts out of balance during the lift operation. Verify outrigger setup, ground support capacity, load weight, and crane stability limits before lifting, and maintain exclusion zones while continuously monitoring ground and equipment conditions. At the construction excavation, the excavator completes its swing cycle and enters the stair access route hidden within the blind area. Excavator swing paths can rapidly occupy large areas around the machine during normal operating cycles. Blind areas develop wherever the boom, stick, bucket, and upper structure restrict visibility along the movement path. At an industrial loading area, an elevated platform bordered an open-top truck, while unstable positioning developed above the open container space. Open-top containers create exposed vertical drop paths wherever elevated surfaces intersect container openings. Stability margins decrease as load position moves beyond the primary support area. Near a residential hillside, elevated tree work suddenly changed direction when a large branch failed without warning. Suspended tree limbs store weight, tension, and leverage throughout the canopy structure. Cutting forces can rapidly redirect branch movement once support fibers separate. At a factory loading dock, a trailer and dock structure occupied a narrowing clearance space as vehicle movement altered the gap geometry. Loading docks contain changing clearances between vehicles, trailers, ramps, and fixed structures. Vehicle movement can rapidly reduce separation distance and create compression hazards within previously open spaces. Inside a warehouse loading area, a forklift continued moving as load stability changed and the vehicle travel path remained active. Forklift operations involve both load movement and vehicle movement simultaneously. Changes in load stability do not eliminate hazards created by the vehicle's continuing travel path and momentum. Inside a tire workshop, several wheel assemblies were stored on the floor when one tire suddenly released its stored energy without warning. Stored pressure hazards can remain within damaged, overheated, overloaded, or deteriorated tire assemblies long after inflation. Structural degradation and internal pressure conditions can rapidly release stored energy if containment integrity is reduced. Inside an equipment wash bay, a wheel loader maneuvered within a confined workspace as equipment travel routes overlapped adjacent movement corridors. Vehicle movement within enclosed work areas creates overlapping travel routes, restricted visibility zones, and reduced separation distances. Equipment movement boundaries should remain isolated from adjacent movement corridors. At the top of an anaerobic tower, fresh coating, trapped solvent vapor, and a welding arc turn maintenance into a pressure release event. Spark permission begins with atmosphere proof. A coated anaerobic tower is a vapor container until testing and ventilation prove it safe. Fresh coating, solvent diluent, and trapped air can turn one welding arc into ignition, verify gas readings, qualify the hot work operator, ventilate fully, and stop the job when the atmosphere is unknown. At a heavy lifting site, crane overload stresses the boom until suspended concrete becomes an uncontrolled falling mass. Confirm crane capacity, rigging geometry, and ground stability before lifting heavy concrete. Keep the entire boom radius cleared. Use load charts without shortcuts. And stop operations when strain, imbalance, or instability appears. At the busy fuel station, a reversing vehicle suddenly enters the fueling bay and knocks down the dispenser. Keep vehicles separated from active fueling areas using barriers, controlled traffic flow, spotters, and protected equipment zones to prevent impact hazards around fuel dispensers and transfer systems. Inside the manufacturing line, a moving machine mechanism suddenly cycles back into position as the active operating area remains exposed. Verify full lockout, zero energy, and complete motion isolation before reaching into machine operating areas, feed systems, or moving mechanisms during maintenance or adjustments. Outside a multi-story building, a heavy air conditioning unit entered a ladder access route when support stability suddenly changed. Oversized loads can rapidly alter balance, visibility, and support conditions within narrow access systems. Combined load weight and movement reduce overall stability margins. In an outdoor utility area, a floor access cover was lifted while an exposed underground opening remained unprotected within the surrounding surface area. Open utility access points create vertical exposure hazards whenever surrounding surfaces remain visually continuous with the opening boundary. Beside a raised dump truck, the elevated bed remained supported above an exposed descending load path, while hydraulic support conditions were under load. Raised truck beds depend on hydraulic systems, mechanical supports, structural integrity, and gravity-dependent load conditions. Any reduction in support capability can rapidly transfer the load path downward. In a factory yard in Hanoi, a tree removal operation altered force distribution within a connected utility pole system. Objects linked by cables, wires, ropes, or attached structures rarely move alone. When force is applied to one part of the system, that energy can travel unexpectedly through connected components, creating hazards far beyond the original work area. Along the exterior wall of a building, an air conditioning unit was supported by a ladder and platform arrangement when the access system suddenly lost stability. Air conditioning units create concentrated loads that require load-rated access systems and stable support geometry. Ladder systems provide access capability but limited working platform stability under equipment loading conditions. At a construction yard, stacked steel beams were secured on a flatbed trailer when the load suddenly shifted during handling operations. Load stability depends on stacking geometry, restraint integrity, support conditions, and balanced force distribution. Changes in restraint conditions can rapidly alter movement paths within stacked steel loads. Inside a narrow roadway tunnel, loss of vehicle control turns a restricted traffic corridor into a chain reaction collision path. Shield roadway maintenance vehicles with advance warnings, crash attenuators, and physical buffers before stopping in restricted lanes. In tunnels or narrow corridors, traffic control must create distance where walls remove escape space. Inside a manufacturing plant, a routine forklift movement suddenly intersects with a high-energy process area and triggers a major explosion. Separate forklift routes from furnaces, fuel lines, and critical machinery using bollards, speed controls, and marked clearances. Industrial vehicles need engineered barriers near high-energy process equipment and vulnerable containment systems during movement. In the warehouse loading area, the load suddenly shifts beyond its balance point as lifting force enters the stack. Material stacks depend on load distribution, support geometry, and center of gravity alignment. Once balance shifts beyond the support area, stored weight rapidly follows the new load path. Inside the equipment wash bay, the tractor rolls toward the narrow work area as the available clearance suddenly disappears between the machine and the wall. Maintain clear separation from loader travel paths and keep out of narrowing clearance areas near walls, barriers, and fixed structures during machine movement and positioning operations. On a narrow mountain dumping road, a raised dump bed suddenly shifted the truck's balance toward the cliff edge. Raised dump beds shift vehicle center of gravity, while bulk material movement alters load distribution. Cliff edge conditions and uneven ground can rapidly reduce vehicle stability margins. Inside a crowded workstation, an open flame suddenly ignited combustible material and transformed a small ignition source into a rapidly growing fire hazard. Combustible materials, electronics, and ignition sources can create concentrated fire growth conditions within confined workstation environments. In a busy container yard, a forklift traveled through an active transport corridor where vehicle and walking routes overlapped. Forklift travel paths and walking routes operate with different speeds. At an industrial yard in Indonesia, a crane was carefully transferring multi-ton steel plates onto a truck when a critical connection high above the load suddenly gave way. Every suspended load depends on hook integrity, rigging condition, wire rope capacity, lifting point strength, and load stability. Failure within any lifting component can instantly remove load support and transfer the full suspended mass back to gravity. Inside a CNC machining center, the machine enclosure remained open while the spindle assembly continued rotating. Rotational energy must be fully dissipated before machine enclosures remain open around rotating tooling. Active spindle systems retain rotational momentum until complete stop conditions are achieved. At a loading area, a large industrial unit transitioned onto a delivery vehicle when load stability suddenly exceeded support capability. Heavy equipment loading depends on stable support surfaces, balanced load distribution, and sufficient load-bearing capacity. Tall equipment can rapidly alter center of gravity conditions when support geometry changes. Inside a confined industrial tower overhead, debris suddenly releases and enters the active work area below. Coordinate simultaneous operations with vertical separation, overhead shielding, and direct communication between levels. Any task above an active work area needs scheduling control, secured tools, and barriers against falling components before access continues. In a farm field, tractor movement creates rear wheel path exposure as stable footing suddenly disappears beside the machine. Stop farm equipment fully before dismounting, set brakes, disengage power transmission, and wait for all motion to cease. Moving tractors create wheel path hazards that cannot be controlled by quick steps or balance. In the woodworking shop, the large timber blank suddenly breaks free from the lathe and launches out of the rotating path. Secure, balance, and verify all lathe-mounted workpieces before startup, and inspect mounting points, clamping systems, and rotational stability to prevent uncontrolled release during machining operations. At the construction site, the crane suddenly loses structural stability as the massive concrete load hangs high above the lift area. Establish large exclusion zones around cranes, suspended loads, and lifting operations, and keep all personnel clear of potential collapse, swing, and drop paths throughout the lift. At an oil storage depot, welding activity near a massive fuel tank suddenly triggered a fast-moving fireball across the work zone. Fuel storage environments combine flammable vapors, ignition sources, and interconnected process equipment. Once ignition occurs, combustion can rapidly propagate through available vapor pathways. Inside a warehouse storage aisle, stacked grain bags suddenly shifted and collapsed into the narrow walking path. Stacked bagged materials generate lateral pressure throughout the storage stack. Uneven loading or poor alignment can suddenly redirect stored weight beyond the original stack boundary. At an industrial park gate in Vietnam, a massive fabric roll began shifting within the trailer as transport forces altered the load position. Large cylindrical loads store momentum and naturally seek a new equilibrium when transport forces change. Turning, braking, acceleration, and directional shifts can rapidly redistribute load forces when restraint systems are insufficient. Inside a Russian factory, a narrow clearance space remained between massive MDF stacks as material stability conditions began changing. Production floors are shaped not only by machines, but by the placement of materials around them. When heavy sheet goods, machine feed tables, and storage stacks are positioned too closely together, ordinary movements can transform available workspace into a powerful compression corridor. On a public roadway, a forklift entered traffic with its forks extended when the equipment's travel path suddenly intersected with an approaching scooter. Forklift travel paths and public traffic routes operate under different speed, visibility, and movement conditions. Route overlap can rapidly reduce available separation distance between industrial equipment and roadway traffic. Inside a busy restaurant, flammable liquid vapors accumulated near an ignition source during a liquid transfer operation. Flammable liquids continuously release combustible vapors during transfer and storage. Vapor accumulation near ignition sources can rapidly create an ignitable fuel-air atmosphere. On a highway, lane position gradually drifts until a parked trailer enters the vehicle's travel path. Manage driving fatigue through rest planning, mandatory pullovers, and early recognition of drifting attention. When alertness drops, the safest control is stopping in a secure location before motion continues under reduced awareness. At a heavy lifting yard, a suspended dump truck shifts mid-air, exposing the instability of improvised rigging. Lift heavy vehicles only with engineered lifting points, balanced rigging, and clearly established drop zones. Suspended machinery requires certified calculations, controlled load paths, tag lines, and properly designed attachments throughout the lift. On the roadside maintenance area, the tractor unit suddenly rolls forward as stored vehicle movement is released unexpectedly. Isolate all vehicle movement sources, verify parking brake effectiveness, install wheel chocks, and secure the work area before beginning maintenance, inspection, or repair activities on heavy vehicles. At a roadside scrap burning area, additional fuel hits an active fire, and the burn zone erupts into a sudden fireball. Treat open fires and hot embers as active ignition sources at all times. Additional fuel can instantly change a controlled burn into a fast-moving fire event, especially when flammable vapor forms between the container and the flame. During a neighborhood garbage collection stop, a garbage truck suddenly erupted into flames beside the loading system. Pressurized hydraulic systems operating near elevated temperatures can rapidly convert fluid leaks into ignition hazards. Escaping hydraulic fluid provides both fuel and dispersal conditions for fire growth. At a demolition site surrounded by loose brick walls, a masonry section suddenly lost stability and collapsed as structural load paths changed. Masonry structures rely on continuous load transfer through connected sections. As support is removed, gravity can rapidly redirect structural forces beyond the original wall alignment. Inside a machine shop, a massive rotating shaft suddenly released stored mechanical energy from the rotating assembly. Industrial machinery doesn't only contain motion, it contains stored energy. When rotating systems, couplings, retaining components, or pressurized assemblies lose their integrity, that energy can be released in every direction at once, extending the hazard far beyond the machine itself. At a demolition site, a large masonry wall experienced changing load paths as structural support was progressively removed. Demolition continuously alters structural support conditions, load paths, and force distribution within the remaining structure. Each removed section changes how gravity transfers load through the wall system. Inside a moving truck cab, an object suddenly penetrated the windshield and turned the driving environment into an uncontrolled hazard. Roadway debris, unsecured materials, and high-speed projectiles can originate outside the primary vehicle travel path. Relative speed and impact energy can allow external objects to penetrate vehicle structures during transport. Inside an industrial processing unit, a pressurized system suddenly lost containment and released stored energy into the surrounding area. Pressurized systems retain stored energy until complete depressurization and isolation have been achieved. Valves, flanges, and process components can release significant force whenever residual pressure remains within the system. On a supply vessel deck, a pressurized line ruptures, turning stored fluid energy into sudden blast movement. Verify pressure ratings, inspection status, and isolation controls before operating high-pressure systems. Maintain clear blast paths, install barriers where practical, and stop operations immediately if leakage, vibration, or abnormal conditions develop. In a glass fabrication workshop, a heavy glass panel begins tipping, turning stored weight into an uncontrolled weight transfer hazard within seconds. Secure vertical glass, stone, and sheet materials using engineered racks, restraints, and controlled handling methods. Once tipping begins, load control systems and restraints must manage the movement, not improvised intervention. High above the construction site, the tower crane's jib suddenly folds inward and the entire lifting structure loses stability without warning. Stop crane operations immediately when structural components, connection points, or load paths show signs of abnormal stress, instability, deformation, or unexpected movement during lifting activities. In the residential driveway, the moving vehicle suddenly loses braking force and rolls straight through the property entrance. Maintain braking systems through regular inspection and testing, and keep driveways, access points, and vehicle paths clear of exposure areas where uncontrolled movement may occur. On a roadside utility pole beside active traffic, a leaning metal ladder suddenly lost ground support and shifted from its stable position. Roadside ladder systems remain vulnerable to vibration, impact forces, and unstable support conditions. Small disturbances at the base can rapidly destabilize the entire structure. In a textile finishing area, fabric streamed continuously from a roller machine when a loose section of material entered the machine's pull path unexpectedly. Keep all loose fabric, clothing, accessories, and body positioning outside active feed paths. Never use the body to support, drape, guide, or tension-moving material near rotating rollers. Use designated handling methods and maintain separation from the machine's draw-in area. At a lifting operation in India, a suspended container remained dependent on lifting system integrity as load support conditions began changing. Suspended loads exist in a temporary state between gravity and control. Every lift depends on cables, hooks, rigging, load balance, and equipment condition working together perfectly. When one element fails, gravity immediately takes over. On a busy street in Venezuela, a moving truck encountered changing roadway conditions as vehicle momentum and surface forces interacted. Vehicle motion continuously transfers vibration, acceleration, braking forces, and roadway inputs through the vehicle structure. Surface irregularities can rapidly alter stability conditions when movement occurs outside protected transport systems. At a busy fuel station, a reversing vehicle struck a fuel dispenser and displaced fuel handling equipment within the fueling area. Fuel dispensers combine vehicle exposure, fuel containment systems, and flammable vapor hazards within the same operating area. Impact damage can rapidly compromise containment integrity and alter fuel release conditions. Inside a manufacturing facility, a forklift transported large panel loads when load stability suddenly changed during movement. Forklift load stability depends on load distribution, restraint integrity, visibility conditions, and vehicle movement dynamics. Elevated materials can rapidly change movement paths if support or balance conditions are altered. On an underground parking ramp, a small work truck rolls backward, turning slope and gravity into uncontrolled vehicle movement. Park incline vehicles with brakes set, transmission secured, and wheel chocks placed before leaving the cab. If rolling begins, clear the travel path and worn downhill areas instead of attempting interception by hand. Inside a Vietnamese manufacturing line, a coiling machine runs with exposed rotation, turning routine approach into entanglement risk. Install fixed guards, interlocks, and controlled approach boundaries around coiling and winding equipment. Keep clothing, tools, and material tails outside rotating paths until power is isolated and all motion has completely stopped. On the oil rig floor at night, the suspended drill pipe suddenly breaks free and drops out of its controlled lifting path. Establish exclusion zones around suspended drill pipe, tubulars, and hoisted equipment, and keep the rig floor clear throughout lifting, positioning, and handling operations. At the roadside entrance, the dump truck approaches the driveway with its body still elevated when the vehicle suddenly loses stability. Lower and secure dump bodies before vehicle movement, and verify overhead clearance, ground conditions, and travel routes before repositioning loaded or unloaded trucks. Inside a rubber processing factory, a shovel near an active grinding system suddenly became trapped in the machine feed path. Grinding systems generate continuous intake force through rotating components and feed geometry. Rigid objects entering the intake path can be rapidly accelerated by the machine's stored rotational energy. At a scrapyard in Andhra Pradesh, a thinner bottle near an active waste fire suddenly erupted beside the burn area. Flammable liquid containers exposed to heat can accumulate expanding vapor pressure internally. Rising temperature increases vapor generation until containment integrity is exceeded. At a container yard in Taiwan, a parked truck remained under the influence of gravity and vehicle weight as restraint conditions changed. Vehicle stability depends on braking systems, wheel restraint, ground conditions, vehicle weight, and load distribution. Gravity continues acting on the vehicle whenever restraint systems are incomplete or ineffective. Inside a warehouse demolition project, a massive masonry wall experienced progressive load redistribution as supporting material was removed. Demolition follows the laws of gravity long before collapse becomes visible. Every block removed changes the wall's balance, shifting loads and weakening the pathways that once carried its weight safely to the ground. Inside a building under renovation, a ceiling light fixture remained unsupported during positioning when the unit suddenly separated from its mounting location. Ceiling-mounted equipment remains dependent on mounting integrity until all support points fully transfer the load. Partial support conditions can rapidly alter load paths and suspended load stability. At a snowy construction site, a truck crane was lifting materials when structural failure sent part of the boom into the active work area below. Crane booms, suspended loads, and lifting components create potential collapse paths, swing paths, and impact boundaries throughout lifting operations. Structural failure can instantly expand these movement paths beyond the intended lifting area. At a construction site, an unseen ignition suddenly releases a violent overhead pressure burst behind the structure. Explosion control begins before the first task, not after smoke appears. Any area with enclosed spaces, fuel lines, solvents, dust, or unknown vapor must be checked as an explosive atmosphere until proven clear. Stop work, isolate energy sources, remove ignition points, verify gas readings, and keep access away from the pressure release path. Inside a busy textile factory, a fabric snag at a high-speed winding machine suddenly redirects material into rapidly spinning rollers. Clear textile winding jams only after shutdown, lockout, and verified zero motion. Interlocked guards, feed tools, and disciplined spacing keep fabric handling away from in-running rollers during production cycles and adjustments safely. At an industrial loading area in Vietnam, a forklift and elevated load suddenly shifted beside a warehouse gate. Forklift stability depends on load height, center of gravity location, and stability triangle geometry. Elevated loads can rapidly alter movement paths when balance conditions change. Forklifts rely on a balanced center of gravity between the truck and the carried load. When a tall or unstable load shifts beyond the stability triangle, gravity rapidly overcomes the counterweight and creates a forward tip or falling load event. Load stability can change rapidly as center of gravity conditions shift. Control the load, maintain safe clearance, and never enter the active load fall path. In the machine shop, the rotating shaft and drive assembly suddenly pull the entire mechanism into motion. Install guards, isolate energy sources, and maintain safe separation from rotating shafts, couplings, and drive systems before inspection, maintenance, or adjustment work begins. In the stamping line, the hydraulic press cycles normally until access enters the active point of operation. Verify full lockout, zero energy isolation, and functional safeguarding before reaching into any press area, and keep all body parts outside active machine operating zones. Hydraulic presses generate extremely high compressive force and complete their stroke much faster than human reaction time. Once a cycle begins, the ram continues through its programmed motion unless stopped by engineered safeguards, interlocks, or isolation controls. The point of operation must always remain protected and isolated before access. At an industrial installation site in Indonesia, a suspended water silo suddenly separated from its supported position. Large suspended structures remain dependent on load balance, lifting integrity, and support geometry. Changes in any of these conditions can rapidly redirect the suspended mass. Inside a crowded storage warehouse, a suspended pallet load suddenly changed direction during material movement. Suspended loads carry momentum that can rapidly change direction when balance, support tension, or transport movement changes. Confined warehouse layouts can compress available clearance around the load path. Suspended loads carry shifting momentum that can rapidly change direction when balance, rigging tension, or transport movement changes. Restricted warehouse layouts can rapidly reduce available clearance around the load path. Suspended loads can rapidly transition from controlled movement to uncontrolled movement. Momentum and changing balance conditions determine the eventual load path. During an elephant bathing session, the animal suddenly altered its balance, posture, and movement path within the work area. Large animals generate dynamic movement forces through changes in posture, balance, direction, and behavior. Unlike mechanical systems, movement patterns can change rapidly without following fixed operating paths or predictable motion sequences. At a pipeline replacement project in Taiwan, the final section of a pipe opening separated and removed a temporary support surface above the exposed opening. When covers, barriers, or cut sections are removed from active systems, support conditions and energy hazards can change simultaneously. Openings may combine fall exposure, pressure differentials, and altered load paths within the same area. The steel plate functioned as temporary structural support until separation occurred. Once support was removed, gravity acted immediately on the unsupported area, while pressure differentials continued influencing movement toward the opening. The final strike is often the point where conditions change the fastest. Every opening should be treated as both a fall hazard and an energy hazard before the cut is completed. At an excavation site, a concrete slab entered the trench area when unstable ground conditions suddenly altered the excavation boundary. Excavations depend on soil stability, trench wall integrity, groundwater conditions, and structural support systems. Changes in ground conditions can rapidly transfer soil and material into the excavation space. Along a roadside property line, a mobile scaffold supported operations near a suspended tree section when load transfer suddenly altered equipment stability. Suspended tree sections create shifting loads that can rapidly alter support conditions and center of gravity relationships within nearby equipment. Access system stability depends on maintaining controlled load transfer throughout the operation. A suspended tree section stores significant potential energy and can swing unexpectedly. Once separated, the sudden transfer of weight can rapidly shift the center of gravity of nearby access equipment. Load transfer continues after material separation occurs. Shifting weight can rapidly change stability conditions within nearby support systems. In an auto repair bay, a sedan shifts on a two-post lift and suddenly turns into an unstable elevated load. Position vehicles on approved lift points test balance at low height and clear the bay before full elevation. Any shift, tilt, or unusual movement means lowering the load and reassessing support immediately. Inside a heavy manufacturing facility, an active CNC gantry milling machine suddenly initiates spindle rotation and program movement across the work area. Control CNC work areas with interlocked barriers, presence detection, and clear floor markings. Automated tables must complete cycles behind guarding because programmed motion continues with force beyond close-range reaction or spoken warning. CNC gantry tables move through programmed linear drives powered by motors and gear systems. Their motion continues along guide rails until the control cycle stops. Without interlocked barriers or presence sensing, the machine applies travel force regardless of objects occupying the table path during operation. Automation needs barriers and sensing because programmed movement will not wait for warning. On the construction hall road, the bulldozer approaches the utility vehicle as both machines converge on the same travel path. Maintain positive separation between heavy equipment and light vehicles. Use designated travel routes and control access around active machine movement areas. In the maintenance yard, a sudden forklift mast movement redirects stored energy through the carriage assembly without warning. De-energize forklift systems, install mechanical blocking, and verify zero energy conditions before working near mast assemblies, carriage mechanisms, or any component capable of unexpected movement. Forklift masts store energy through hydraulic pressure, lift chains, rollers, and elevated carriage components during operation. A control input, hydraulic drift, or mechanical release can instantly transfer that stored force into the mast and fork assembly. Treat every movable mast component as energized until properly isolated and blocked. Inside an elevated rail platform, a suspended rope contacted energized equipment and triggered a massive arc flash across the platform structure. Conductive materials entering high voltage clearance boundaries can create unintended electrical paths. Electrical energy may bridge air gaps through arcing when sufficient voltage and proximity exist. At a warehouse loading dock, a reversing forklift entered a shared movement corridor beside the trailer bay. Shared movement corridors create visibility conflicts whenever forklift travel routes overlap adjacent circulation paths. Reversing movement further expands blind areas and rear swing exposure. Forklifts create expanding blind areas during reversing and turning movement. Rear counterweight swing can rapidly alter available clearance around the machine travel envelope. Shared movement corridors concentrate multiple movement paths into limited space. Separate equipment routes and walking access before any vehicle movement begins. At a truck loading area in Peru, bundled steel bars remained stacked on a trailer when load stability suddenly changed. Secured loads remain stable only while restraint systems and load distribution remain intact. Once restraint integrity is reduced, stored weight rapidly follows changing load paths under gravity. On a busy city street, an excavator brought down a concrete wall as the collapse path extended beyond the primary demolition area. Demolition hazards extend beyond the structure itself. Once support is removed, gravity, momentum, fragmentation, and changing load paths can expand the collapse area beyond the original structure footprint. As the excavator weakened the wall, its center of gravity shifted away from its remaining support. When the structure finally failed, the stored weight converted into rapid downward and outward movement, scattering debris beyond the work zone. Collapse boundaries are determined by load paths, momentum, and fragmentation distance. Adjacent travel routes can rapidly become part of the collapse zone when structural support is removed. In an underground haulage area, a loaded cart approached an elevator shaft while the transfer platform was absent, leaving an open path directly ahead. Open shaft locations create a direct vertical exposure whenever transfer platforms are absent. Protection systems, platform position, and barrier integrity determine whether the shaft remains isolated from adjacent movement routes. In a narrow alleyway beside an aging residential building, part of an exterior structure suddenly detached and collapsed into the area below. Long-term material degradation can reduce structural capacity within exterior building components. As support connections weaken, gravity can redirect structural loads beyond the original support system. Weathering, moisture intrusion, and long-term material degradation can gradually weaken structural connections over time. Once the remaining support capacity is exceeded, sections can fail suddenly and release debris into the area beneath. Structural degradation often develops long before visible failure occurs. As support capacity decreases, gravity ultimately determines the load path. At a roadside unloading area, a crane truck boom reaches overhead lines, turning material delivery into electrical arc exposure. Survey overhead utilities before boom movement, assign a spotter, and maintain required electrical clearance at every angle. If line visibility changes, stop the lift and reposition only after hazards are confirmed clearly. At an urban excavation site, a massive excavator increases ground loading until a nearby retaining structure suddenly fails. Keep excavators and spoil loads back from unsupported edges with shoring or engineering controls installed before digging. Ground pressure from heavy equipment can overload soil and retaining walls without visible warning during excavation. An excavator adds concentrated ground pressure beside an unsupported excavation. As the boom reaches, the machine's weight distribution shifts and increases lateral stress on soil and retaining walls. If shear resistance is exceeded, the wall rotates or slides into the open trench without warning signs. Unsupported excavation edges cannot safely absorb excessive loading, vibration, and equipment pressure. Engineering controls must be established before excavation advances. In the busy bicycle repair shop, an invisible vapor cloud suddenly finds an ignition source beside the freshly applied adhesive. Keep open flames, sparks, and heat sources away from adhesives, solvents, and chemical products, and ensure adequate ventilation before handling or drying flammable materials. In the factory storage yard, the towering stack of compressed textile bales suddenly shifts and collapses beside the active travel path. Verify stacking stability, maintain exclusion zones, and keep travel routes clear around compressed bales, pallets, and other high-stacked materials susceptible to shifting. Compressed textile bales carry significant weight, and tall stacks create a high center of gravity that becomes increasingly unstable with height. If alignment shifts or support layers deform, gravity can rapidly pull multiple bales into a cascading collapse. Unstable stacks can collapse without warning once balance is lost. Inside a workshop handling open containers of flammable liquid, vapor suddenly ignited into a fast-moving fireball. Flammable liquid vapors can accumulate far beyond the original container location. Once vapor concentration enters the ignitable range, ignition can rapidly propagate through the surrounding airspace. On a roadside optical cable route, an elevated ladder system suddenly lost stability beside energized utility infrastructure. Elevated access systems depend on stable support geometry, secure footing, and balanced loading conditions. Nearby utility infrastructure can further reduce stability margins and available clearance. Ladders lose stability when shifting loads. Lateral force or uneven support move the center of gravity beyond the support base. Once balance is exceeded, gravity rapidly redirects the structure. Elevated access systems remain dependent on continuous stability. Secure the ladder, harness, and surrounding hazards before every climb. Inside an auto repair shop, a vehicle entered the alignment bay approach, while momentum remained unchanged within the confined workspace. Vehicle movement inside confined workspaces combines momentum, restricted clearances, fixed structures, and limited stopping distance. Changes in vehicle speed or travel path can rapidly alter energy conditions within the bay area. On a logging truck, stacked timber lost load stability as unloading forces altered the balance of the pile. Round materials such as logs create unstable surfaces because every movement changes the load's balance. A single shift can transfer weight through the entire stack, turning a stable pile into a rolling mass. Logs naturally seek the lowest energy position and can rotate when restraints are removed or footing changes. As load pressure redistributes, gravity drives movement through the stack, causing multiple logs to roll in sequence. Timber stacks can store significant movement potential through load pressure and unstable geometry. Changes in balance can rapidly transfer force through the entire stack. Inside a home kitchen, a small stovetop oil fire suddenly expanded when water contacted the burning fuel surface. Cooking oil fires involve burning fuel that can rapidly spread when disturbed. Water contacting high-temperature oil instantly converts to steam and can disperse burning fuel across a larger area. Inside a warehouse, a forklift transported a large load when material stability suddenly changed during movement. Forklift loads must be secured and kept stable throughout transport, including during turns, stops, and changes in direction. Keep all personnel outside the potential fall path of elevated or unsecured materials. Forklift load stability depends on balanced load distribution, restraint integrity, travel dynamics, and support conditions. Changes in direction, speed, or load geometry can rapidly alter material movement paths. Elevated materials store gravitational potential energy throughout transport. Changes in load stability can rapidly convert stored energy into downward movement. In a roadside excavation, impact force applied to a vacuum pipe during maintenance suddenly released trapped pressure differential energy. Verify the energy status of every vacuum system before striking, cutting, loosening, or dismantling any component. Vacuum lines can retain pressure differences, weakened sections, and residual force that may shift components without warning. Isolate, depressurize, inspect, and choose the correct work method before maintenance begins. Inside a factory freight elevator bay, a moving platform and fixed wall created a narrowing clearance that turned routine access into a zero-escape pinch path. Keep all access outside the elevator travel path until motion is stopped, locked out, and verified. Any gap between a moving lift platform and a fixed wall must be guarded, isolated, or physically blocked before close-range activity begins. A lift moving against a fixed surface creates a converging pinch point with no natural release space. Once travel continues, the motor force keeps closing the clearance until controls are stopped or energy is isolated. Moving platforms require hard barriers, safe clearance, and lockout before entry. No task belongs inside an active elevator travel path. Outside the work area, a loose shirt drifts into the rotating power tool and suddenly enters the moving path. Wear fitted clothing, secure loose garments, and remove jewelry before operating rotating power tools to prevent material from entering the rotation or entanglement path. At the container yard, the loaded dump truck suddenly begins moving beside the fence as one overlooked control releases the vehicle's stored energy. Verify parking brakes, vehicle securement, and ground conditions before leaving any parked truck, and use additional controls where unintended movement could create a travel path hazard. A loaded truck stores significant gravitational and rolling energy, especially when parked on uneven or sloped surfaces. If the parking brake is not fully effective or the vehicle is not properly secured, gravity can quickly overcome resistance and initiate uncontrolled movement. A parked vehicle is only safe when its movement is fully controlled. Outside a roadside building facade, a rolling scaffold suddenly shifted and collapsed across the surrounding surface area. Mobile scaffolds depend on wheel restraint, ground conditions, and balanced load distribution. Movement, vibration, or uneven surfaces can rapidly reduce structural stability. On a residential driveway, a recycling bin suddenly tipped as downward pressure forced the unstable container to shift sideways. Rolling containers rely on wheel position, support geometry, and center of gravity location for stability. Load shifts can rapidly move the balance point outside the support footprint. Trash bin lids flex and shift under concentrated weight, especially when the load is uneven or the wheels can roll freely. As the container deforms, the center of gravity moves outside the support base, creating sudden, uncontrolled movement. Improvised support surfaces can lose stability with minimal load movement. Center of gravity shift ultimately determines whether the structure remains upright. Beside a roadside repair area, a parked vehicle occupied a confined maintenance space, while heavy equipment moved through an adjacent travel path. Vehicle maintenance areas and mobile equipment routes create overlapping movement paths and compression hazards. Unexpected vehicle movement can rapidly reduce available clearance within confined workspaces. On a narrow road in India, a tanker truck entered motion while blind zones overlapped the vehicle travel path. Large vehicles generate extensive blind zones and restricted visibility areas around the travel path. Route overlap between vehicle movement and adjacent access paths can rapidly reduce available separation distance. A loaded tanker carries substantial momentum even at low speed. Restricted visibility around the vehicle can create overlap between blind zones and adjacent travel routes. Large vehicles combine momentum, blind zones, and extended stopping distances within restricted travel areas. Movement paths require verified separation from adjacent access routes before vehicle motion occurs. At a gym bench press station, a heavily loaded barbell suddenly moved outside the controlled rack support position. Loaded barbells store gravitational force whenever the weight remains unsupported by the rack structure. Stability depends on maintaining controlled support and alignment throughout the lifting cycle. Inside a manufacturing facility, an enclosed molding machine suddenly initiated a machine cycle while stored energy remained available within the system. Molding machines can retain hydraulic, pneumatic, electrical, and mechanical energy after visible motion stops. Stored energy remains capable of initiating machine movement until complete isolation has been achieved. Molding machines store energy through hydraulic, pneumatic, electrical, and mechanical systems. If a cycle command occurs while energy remains available, machine components can move rapidly with significant force. Stopped motion does not indicate zero stored energy. Machine movement remains possible whenever energy sources remain available. At Samsung's Pyeongtaek Construction Road, forklift travel and signaling activities overlap within a narrow work lane, creating blindside movement exposure. Separate pedestrian routes from forklift travel lanes using barriers, markings, and controlled crossings. Where visibility is restricted, stop machine movement until spacing, traffic control, and line-of-sight conditions are fully established. In an industrial yard, a motorized wire spool keeps rotating, turning loose fabric near the drum into an instant snag hazard. Create fixed clearance around wire spooling equipment and control loose fabric before rotation starts. Operators should use guides, guards, and emergency stops while keeping all positioning outside the drum path during work. A wire spool uses rotational torque to pull and wind material under tension. Loose fabric touching the drum gains frictional grip and begins wrapping around the rotating surface. The motor's stored and supplied energy keeps increasing tension until the system stops or releases during operation. Wire spools require distance control. Loose material must stay away from live rotation. Inside the factory rest area, the seemingly solid masonry wall suddenly loses stability and collapses above the occupied space. Establish rest areas, workstations, and storage spaces away from damaged, unsupported, overloaded, or structurally compromised walls, and verify structural integrity before adjacent areas are occupied. In the residential driveway, the wheeled recycling bin suddenly shifts under load and turns the improvised platform into an unstable support surface. Use only stable ladders or step stools designed for body weight, and keep off wheeled bins, carts, or containers that can shift unexpectedly under load. A wheeled bin has a narrow support base and a high center of gravity, making it inherently unstable as a standing surface. As weight shifts, the wheels can roll or pivot unexpectedly, causing the support point to move and balance to be lost almost instantly. Wheeled containers are storage tools, not access platforms. At a brick construction site, a long, unsupported wall suddenly folded outward as temporary bracing gave way under shifting structural pressure. Partially completed masonry walls depend on temporary bracing, structural continuity, and lateral support. Wind, vibration, and changing load distribution can rapidly reduce wall stability. Inside a recycling facility, a hydraulic compactor cycle activated while access to the compression chamber remained open. Hydraulic compactors combine stored hydraulic energy, automated controls, and compression movement within a confined chamber. Motion can reinitiate whenever energy sources remain available to the system. Hydraulic compactors generate large compressive forces through pressurized cylinders and controlled ram travel. Available hydraulic energy can rapidly drive the compression plate through the chamber path once a cycle is initiated. Automated compression systems can retain motion capability after visible activity stops. Stored energy and control signals determine movement within the chamber. At an industrial entrance, two metal gates simultaneously bridged separate electrical potentials through a conductive path. Electricity can energize conductive metal structures whenever different electrical potentials become connected. Any conductive path linking separate potentials can immediately allow current flow through the circuit. Inside an industrial work area, a pressurized cylinder lost containment when a critical connection suddenly separated from the system. Pressurized systems store energy long before anything moves. When a fitting, valve, or restraint fails, that stored force can convert stationary equipment into high-speed motion without warning. Compressed gas contains significant potential energy. If a valve assembly, fitting, or connection separates unexpectedly, the escaping gas creates thrust in the opposite direction, accelerating the cylinder like a rocket and producing unpredictable movement across the work area. Pressure is invisible, but its force is always present. When containment fails, stored energy becomes motion in a fraction of a second. Outside a tire service area, an inflated truck tire suddenly failed and launched the wheel assembly beyond its original position. Inflated tire assemblies can retain significant stored energy even while stationary. Structural failure of the tire or wheel assembly can rapidly convert contained pressure into high-speed movement. Inside a warehouse, an unsecured plank supported by a forklift suddenly lost balance at an elevated position. Improvised elevated platforms depend entirely on support geometry and center of gravity stability. Small shifts in load position can rapidly move the system outside its stable support boundary. A plank supported at height remains stable only while its center of gravity stays within the support footprint. Once the balance point moves beyond that boundary, gravity rapidly rotates the system toward a new equilibrium position. Improvised support systems can lose stability with minimal load movement. Support geometry ultimately determines whether elevated loads remain balanced. At an agricultural grain pit, access routes beside a rotating conveyor create a fast-moving draw-in hazard near the equipment path. Stop the conveyor before clearing jams, accessing rollers, or crossing moving components. Guard nip points, separate walkways from drive systems, and ensure emergency stops remain accessible from all operating positions. Inside a production press area, access beneath the machine coincides with stored energy as the press cycles again before clearance is established. Don't inspect beneath the press while stored energy, auto cycle settings, or control power remain active. A press opening is not a safe access point until motion is isolated, the cycle is locked out, and the RAM is secured against repeat movement. Use lockout, block the press, verify zero energy, and restart only after the inspection area is fully clear. A press converts motor force, hydraulics, or pneumatics into sudden downward motion. If the cycle repeats, the closing stroke follows its set path faster than manual reaction. Secure the press before looking inside. No isolation, no inspection. On the roadside recovery scene, the overturned dump truck suddenly fails during the lift and blasts debris and dust across the recovery area. Maintain large exclusion zones around damaged vehicles during recovery operations and keep clear of potential debris, swing, rollover, and structural failure paths throughout the lift. Outside the factory entrance, stacked shelving frames suddenly lose stability and collapse into the occupied area beside the forklift travel route. Establish break areas, waiting zones, and routine activities outside material handling routes, and maintain exclusion zones around stacked or elevated loads during movement operations. Raising the tall shelving frames increased the load's center of gravity and reduced stability during transport. As the stack shifted beyond its support line, gravity rapidly pulled the interconnected frames into a cascading collapse. Break areas must remain completely outside active material handling and load collapse paths. Inside a steel structure, an elevated ladder access point was being used when carrying an item during the climb, which led to a sudden loss of balance. Keep 3 points of contact while climbing at all times. Materials, tools, and equipment should be lifted separately using approved methods, not carried in the hands during ladder access. Inside a machine shop, an active gantry travel mechanism was operating when a nearby reach entered the machine's moving path unexpectedly. Establish and maintain a clear exclusion boundary around energized gantry systems, moving rails, and travel mechanisms. Do not place any object, tool, or material within machine movement clearances until all motion has been stopped and isolated. Gantry systems generate continuous linear motion through powered drives and guided rails. Any object entering the clearance space can become trapped between moving and fixed components as machine force rapidly eliminates available clearance. Machine movement requires only a small clearance breach to create a hazard. Respect travel path boundaries, maintain separation from energized equipment, and verify zero motion before entering machine clearances. Seize. At a tire yard in China, a forklift lifted a stack of heavy truck tires when load stability suddenly changed on the forks. Round materials require minimal force to initiate movement. Once balance changes, gravity and momentum can rapidly transfer force through the load and create rolling movement paths. At a construction site, a crane-lifted stack of concrete blocks suddenly moved outside its intended lifting alignment, mid-air. Suspended loads can rapidly alter their movement path when load balance, rigging tension, lifting geometry, or center of gravity conditions change. Load movement boundaries extend beyond the intended lifting position throughout the lift. Crane lifts depend on the load's center of gravity remaining aligned beneath the lifting point. If the load tilts, shifts, or experiences uneven force distribution, the suspended mass can swing, rotate, or separate from its intended path, releasing large amounts of energy through momentum and gravity. Suspended loads remain dynamic systems throughout lifting operations. Load stability depends on maintained lifting geometry, balanced force distribution, and rigging integrity. Along a construction site boundary, a freestanding concrete wall suddenly lost stability and collapsed into the adjacent excavation area. Freestanding and partially supported walls remain dependent on ground support, structural continuity, and surrounding soil conditions. Excavation activity can alter support relationships and change wall stability. At a warehouse loading dock, a reversing truck maneuvered into position as clearance between the vehicle and a fixed structure rapidly decreased. Reversing operations create compression hazards wherever vehicle travel paths overlap fixed structures. As clearance decreases, available separation distance can disappear rapidly within confined loading areas. Large vehicles generate significant momentum and continuously reduce clearance during reversing movement. In confined spaces, gap reduction often occurs faster than the available distance can absorb the movement. Reversing movement continuously alters clearance geometry within confined areas. Compression hazards develop wherever vehicle travel paths converge with fixed structures. Inside a processing plant, a sealed vessel hatch opens under pressure, turning stored gas energy into a projectile event. Depressurize vessels completely before loosening hatches by using gauges, bleed valves, isolation controls, and lockout verification. Stored gas energy remains active until zero pressure conditions are confirmed through authorized procedures. Deep in an underground mine, a personnel elevator cage loses position and turns vertical transport into a sudden drop hazard. Establish positive hoist control before cage access begins. Confirm brake function, cage position, signal communication, and gate interlocks so transfer points remain secured throughout loading and unloading operations. A mine elevator cage depends on hoist cables, brakes, and control signals to maintain position. If braking force is lost or a command error occurs, gravity accelerates the cage downward. Open gates worsen exposure because the platform is no longer positively restrained during the transfer. Mine hoists need locked control before cage boarding starts. At the material loading area, a small shift in the bundled brick stack suddenly triggers a cascading collapse during wheel loader unloading operations. Maintain exclusion zones around stacked masonry products and keep loading, unloading, and material transfer operations clear of potential collapse paths. On the bridge construction deck, a steel bundle suddenly shifts out of position and triggers a rapid collapse through the stacked material line. Maintain exclusion zones around stacked steel storage areas. Use chocks and restraints to prevent movement and control access around unsecured or elevated material bundles. Long steel sections carry substantial weight and can behave as a connected mass when stacked closely together. Once support or friction is lost, gravity rapidly transfers force through adjacent members, causing sections to slide or topple in sequence. Steel bundles can collapse instantly once a single section loses stability. Inside a machine shop, maintenance work is underway beneath a large radial drilling machine when the spindle assembly suddenly returns to motion. Before entering any machine movement envelope, isolate and lock out all energy sources. Verify zero motion, and confirm the equipment cannot restart. Maintenance access should never begin until machine movement has been positively eliminated. Inside a warehouse loading lane, a forklift shifted a stacked cargo load sideways across a truck bed surface. Cargo stability depends on load alignment, support geometry, and force distribution during forklift contact. Small positioning errors can redirect load force laterally instead of vertically. Forklifts transfer loads through forward mast force and concentrated fork pressure during lifting alignment. If fork positioning is uneven or offset, the contact force can push the cargo laterally instead of lifting it vertically. Load alignment directly influences force direction during material handling. Small contact changes can rapidly alter the movement path of heavy cargo. At a roadside loading area in Ghana, a bulldozer entered a low-bed trailer as trailer position and equipment alignment suddenly changed. Loading operations depend on controlled equipment position, trailer stability, and predictable movement paths. Any unintended movement can rapidly alter clearances, load paths, and equipment alignment conditions. On a sloped roadside, a trailer lost positive restraint and began moving under gravitational force. Gravity is a silent force until restraint disappears. The moment a heavy load loses its secure connection, every kilogram begins following the path of least resistance. A trailer parked on an incline stores gravitational potential energy. When coupling systems, wheel restraints, or parking controls fail to maintain restraint, that energy converts into motion and accelerates the trailer downhill under its own weight. The primary hazard is uncontrolled movement following loss of restraint. Once gravity becomes the driving force, trailer motion continues until another force alters the travel path. At a hospital elevator, the elevator car began moving while a clearance conflict remained between the car and landing entrance. Elevator systems depend on door interlocks, clearance integrity, and position control to separate moving components from surrounding structures. Any loss of clearance can rapidly create compression hazards between the car and landing. Beside a dump truck loaded with demolition debris, a large concrete fragment near the top of the load suddenly shifted and dropped from the elevated truck bed without warning. Demolition debris loads depend on stacking stability, restraint integrity, and support geometry. Elevated fragments can rapidly enter gravity-driven movement paths when vibration, shifting loads, or unstable placement reduce support. Elevated materials store gravitational potential energy. When vibration, movement, or unstable stacking reduces support, that energy converts into rapid downward motion with little warning. Elevated debris retains gravitational potential energy throughout transport and handling. Changes in support conditions can rapidly convert stored energy into downward movement. Inside a metal recycling furnace, hidden moisture reaches molten metal and instantly transforms into expanding steam beneath the surface. Ensure all furnace feed material is dry, inspected, and introduced at a controlled rate. Maintain separation from potential pressure release paths whenever molten metal processing is underway. Inside a delivery truck, a bent tailgate, control turned one quick look into the cargo area into an unexpected closing movement at the rear opening. Separate inspection from control contact. Any tailgate switch that is bent, exposed, or positioned near the access path must be repaired, guarded, or isolated before the rear opening is used. A powered tailgate creates a heavy rotating closure path, and even a small accidental input can activate full movement. Once the panel starts closing, hydraulic force and panel weight remove safe clearance fast. Guard the controls before working near powered tailgates. A damaged switch can turn normal access into sudden closing edge exposure. At the residential work area, an unsecured tool suddenly drops from above and falls directly into the ladder access path. Secure all tools, materials, and equipment when working at height, and keep ladder access routes clear of overhead falling object hazards and unsecured items. Inside the deep excavation, the trench wall suddenly gives way beside the excavator bucket and collapses into the work area. Use trench protection systems, inspect soil conditions regularly, and prohibit access to excavations with unsupported sidewalls, unstable ground, or nearby vibration sources. Excavation walls depend on soil strength and stability to resist the forces acting against them. When gravity, vibration, moisture, equipment loading, or disturbed ground exceed that strength, the soil mass can rapidly collapse into the excavation. Unsupported excavation walls can fail instantly when ground conditions change. Inside a narrow food stall workspace, exposed electrical wiring energized a metal surface beside an active cooking station. Exposed conductors, damaged insulation, moisture, and conductive metal surfaces can combine to create unintended electrical paths within confined work environments. At a fuel loading platform, vapor buildup ignited suddenly on an active tanker transfer operation. Fuel transfer operations combine flammable vapors, static discharge potential, ignition sources, and interconnected fuel pathways. Vapor ignition can rapidly propagate across the transfer environment. Fuel vapors can spread rapidly through confined or partially enclosed loading areas and ignite from a tiny static or electrical spark. Once ignition occurs, expanding combustion gases create a fast-moving pressure wave and intense thermal flash around the tanker surface. Fuel vapor ignition can spread rapidly throughout a transfer area. Combustion follows available vapor pathways and ignition conditions. On a narrow street in India, a cement bag suddenly separated from an elevated position above the access route. The load path beneath elevated material extends beyond the lifting equipment itself. Any area beneath suspended or elevated material remains exposed to gravity-driven movement if support is lost. Inside a CrossFit gym, rotational momentum rapidly increased around a high bar movement path as balance conditions changed. Rotational systems depend on controlled momentum, stable pivot points, and balanced force distribution. Small changes in rotational geometry can rapidly alter movement paths and energy transfer. Angular momentum continuously changes throughout rotational movement around a fixed pivot point. Variations in force distribution, rotational timing, or pivot geometry can redirect stored kinetic energy into a new movement path. Rotational energy increases rapidly as speed and angular momentum combine. Movement stability depends on maintaining controlled force distribution throughout the rotation cycle. Along a highway construction corridor, a crane working on a steep embankment suddenly lost stability, sending the boom into the adjacent traffic path beside active vehicles. Construction equipment operating on embankments depends on ground stability, load distribution, and support geometry. Loss of stability can rapidly expand boom paths, collapse paths, and movement boundaries beyond the original work area. On a freshly paved roadway, a narrow clearance developed beside an operating road roller as adjacent travel paths converged. Road rollers require substantial operating space due to vehicle width, mass, and limited maneuverability. Converging travel paths can rapidly eliminate available lateral clearance around the machine. Road rollers have substantial mass, limited steering response, and minimal side clearance tolerance. A small loss of balance in a restricted space can quickly redirect movement into the machine's travel path. Restricted clearances provide little tolerance for movement path changes. Large equipment can rapidly occupy available lateral space during operation. In an excavation trench, cutting into a sealed industrial pipe releases hidden pressure faster than the work can be controlled. Confirm zero pressure before cutting sealed pipes using isolation, draining, bleeding, and gauge checks. Cutting tools should touch the line only after stored liquid or gas energy is fully controlled and logged. At an outdoor transport site, a mobile crane lowers a massive container as suspended load movement develops above the placement area. Establish clear deck exclusion zones during container placement. Control swing with taglines from protected positions and keep suspended loads isolated from active work areas until fully landed and secured. A crane-lowered container behaves like a pendulum when its center of mass moves below the rigging point. Small shifts, wind, or uneven lowering create swing. As the suspended load arcs, momentum carries it beyond the intended set-down area unless controlled remotely from outside the deck. Suspended containers need remote control methods, not close-range corrections during swing. On a narrow urban street, a garbage truck sat waiting in traffic when the pavement beneath it suddenly gave way. Assess roadway conditions around utility corridors, excavations, and aging infrastructure, and establish exclusion zones where hidden subsurface instability could affect vehicle operations. On the uphill roadway, the concrete pipe sections suddenly break free from the flatbed truck as the vehicle rounds a bend. Secure cylindrical loads with engineered restraints, chocks, and blocking systems designed to resist rolling, shifting, braking, turning, and road vibration forces during transport. Concrete pipe sections naturally resist staying in place because their curved shape allows rolling movement when lateral forces are applied. During cornering, inertia pushes the load outward, and insufficient securement can allow the pipes to shift beyond the restraint system. Cylindrical cargo can become unstable quickly when securement is inadequate. On a nighttime drilling rig, suspended pipe handling suddenly changed stability above the rig structure. Suspended drilling components remain dependent on load balance, lifting integrity, and support geometry. Apparent stillness does not eliminate stored gravitational force within the suspended system. Inside a tire repair bay, compressed air energy built silently inside a heavy truck tire assembly. Commercial tire assemblies store substantial compressed air energy during inflation and bead seating. Structural failure can rapidly convert stored pressure into force, pressure waves, and component projection. Commercial tires store massive amounts of compressed energy during inflation and bead seating. If structural failure, bead separation, rim damage, or overpressure occurs, that stored energy releases instantly as a violent pressure wave and debris projection. Compressed air remains stored energy throughout tire inflation. Containment failure rapidly transforms pressure into movement and force. At an industrial yard, a suspended concrete pipe remained dependent on lifting system integrity as load support conditions suddenly changed. Heavy suspended materials can rapidly alter their movement path when load balance, rigging tension, or lifting geometry changes. Swing paths, acceleration paths, and impact paths can expand immediately after load instability develops. At a fuel transfer station in Libya, flammable vapor accumulated around the transfer hose when an ignition source suddenly reached the vapor cloud. Fuel transfer operations operate on a razor-thin margin between controlled flow and uncontrolled energy release. Once an ignition source meets a flammable vapor cloud, conditions can escalate in seconds. Liquid fuel continuously releases vapors that can accumulate around transfer points. A static discharge, spark, or ignition source can ignite those vapors, creating a rapidly expanding flame front that follows the fuel-air mixture. Fuel transfer hazards develop rapidly when ignition sources interact with flammable vapor atmospheres. Containment integrity, vapor control, and ignition separation determine hazard growth. Inside a deep excavation, a large section of unsupported trench wall suddenly broke loose and collapsed into the excavation, rapidly filling the work area with soil and debris. Excavation stability depends on soil strength, moisture content, vibration exposure, support systems, and trench geometry. Changes in these conditions can rapidly redirect surrounding material into the excavation. At a high-rise construction project, a tower crane mounted beside the structure began swaying violently during a major earthquake, causing the jib and mass sections to lose stability high above the site. Tower cranes in seismic environments remain subject to lateral acceleration, oscillation, and dynamic structural loading. Extreme ground movement can alter load distribution throughout the crane and supporting structure. Earthquake forces create rapid lateral acceleration throughout a structure. When oscillation exceeds design limits, stress concentrations can overload crane components and connections. Seismic loading can rapidly exceed normal structural loading conditions. Oscillation and lateral acceleration can redistribute forces throughout large structures and equipment. Inside a freight elevator, excess loading pushes the lift platform beyond its intended operating capacity and creates a sudden drop hazard. Verify combined cargo weight before loading any freight elevator. Rated capacity limits must include carts, racks, trays, materials, and all transported equipment to prevent overload conditions. Inside a factory production line, an industrial machine unexpectedly restarts and turns the machine opening into an active closing stroke hazard. Isolate control power, stored pressure, and automatic cycling before access begins. Machine openings remain active motion paths until lockout, guarding, and zero energy verification are fully completed. Hydraulic or mechanical drives can complete a stroke faster than manual reaction. Once the cycle command returns, the ram follows its program path. Lockout before reaching in. No verified isolation, no access. In the busy container yard, the massive container handler begins reversing as movement enters the narrow equipment travel path. Maintain clear separation from container handling equipment. Establish exclusion zones around turning envelopes and travel paths. And verify visibility and clearance before access to operational areas. On the roadwork area, the scooter suddenly loses stability beside the active road roller and enters the machine's travel path. Maintain a safe buffer around active compaction equipment. Establish separation from machine travel paths and keep public traffic outside construction machinery operating areas. Road rollers have limited visibility around the drums, corners, and immediate travel path during operation. When a scooter loses stability near heavy equipment, the available separation distance can disappear almost instantly as both paths converge. Keep clear separation between two-wheeled vehicles and active heavy equipment at all times. Inside a deep excavation trench, unstable trench walls suddenly failed as excavation forces and surrounding ground conditions changed. Excavation stability depends on soil strength, moisture content, vibration exposure, surcharge loading, and trench geometry. Changes in these conditions can rapidly redirect surrounding material into the excavation. Inside a metal fabrication workshop, a large steel workpiece suddenly entered uncontrolled rotation seat beneath a powerful drill press. Drill presses transfer rotational torque directly into the workpiece during cutting. Unrestrained material can rapidly absorb rotational energy and change movement direction. As the drill bit cuts into metal, rotational torque can instantly grab and spin unsecured material at high speed. Larger drill diameters and stronger machine torque dramatically increase rotational force and uncontrolled movement energy. Rotational torque can rapidly transfer from machine to material. Unrestrained workpieces may become moving hazards once cutting begins. At a construction site, a crane began lifting a bundle of steel formwork panels when the suspended load suddenly shifted sideways. Suspended loads can rapidly change direction when balance, lifting geometry, or rigging tension changes. Load movement boundaries can expand well beyond the hook position once instability develops. At a public tractor pulling event, two tractors strained against each other through a chain connection, while enormous forces built with every second of tension. When heavy vehicles pull against resistance, energy doesn't disappear. It accumulates throughout the machine, tires, driveline, and connection points. A sudden loss of balance or traction can release that energy in an unpredictable direction. As pulling force increases, the tractor's center of gravity shifts rearward, while torque transfers through the drivetrain to the wheels. If traction, load distribution, or stability limits are exceeded, rotational forces can rapidly lift and overturn the machine. Stored force can rapidly convert into uncontrolled motion when stability limits are exceeded. Traction changes, load shifts, and rotational forces can alter vehicle movement paths instantly. On a two-lane roadway, a turning semi-trailer extended into the opposing traffic lane as vehicle paths converged. Large articulated vehicles require additional roadway width during turning due to off-tracking and trailer swing. Turning movements can expand the vehicle envelope beyond the primary travel lane. At a truck tire service area, a wheel assembly suddenly lost containment and released stored pressure energy into the surrounding area. Truck tire assemblies remain stored energy systems whenever compressed air remains contained within the tire structure. Loss of containment can rapidly convert stored pressure into force, pressure waves, and component movement. Compressed air inside a heavy-duty tire stores substantial potential energy. If the tire, rim, or assembly fails, that energy is released almost instantly, creating a powerful pressure wave and rapid component movement. Stored pressure remains present even when tire assemblies appear stationary. Containment failure rapidly converts potential energy into kinetic energy and pressure release. Inside a commercial bakery, an industrial dough mixer continues rotating while open access remains exposed near the mixing zone. Keep mixer access guarded throughout active cycles and use shutdown procedures before scraping, clearing, or adjusting dough. Rotating arms and bowl clearances demand separation until all stored motion is gone completely before restart. At a loading dock, stacked glass panels begin shifting on an A-frame rack and rapidly redirect their weight beyond the support line. Unload glass panels with restraints released in sequence, mechanical assistance ready, and clear standing positions. A-frame racks need controlled balance so stacked sheets cannot shift outward suddenly during handling or staging work. Glass panels on an A-frame rely on angle, friction, and restraint straps for stability. Removing restraints too broadly lets the combined mass shift outward. Once the center of gravity passes the rack support line, the stack rotates down under its weight without controlled mechanical support. Glass unloading needs restraint released slowly, with balance controlled before each panel moves. At the rail crossing beside the fuel dispenser, a routine moment suddenly erupts into a massive flash as the train enters the active travel path. Install protective barriers, maintain clearance distances, and keep fuel dispensing equipment completely outside active rail and vehicle travel paths to prevent impact-related fuel hazards. At the fire-damaged building, a hidden structural weakness suddenly gives way as the overhead structure appears stable from the outside. Treat all fire-exposed roofs, floors, and structural elements as potentially unstable, and maintain collapse zones, restricted access, and continuous structural assessment after fire events. Fire can significantly weaken structural members, connections, and support systems long before visible signs of failure appear. Once the remaining load-bearing capacity is exceeded, sections of the structure can collapse suddenly with little or no warning. Fire damage can hide critical structural instability long after the flames are gone. Near an outdoor burn barrel, fuel was poured onto active flames when the fire suddenly erupted back out of the container. Flammable liquids exposed to active combustion can produce rapidly igniting vapor clouds. Additional fuel introduced to an existing fire significantly increases available combustion energy. In a backyard, a tensioned tree branch suddenly redirected stored force and changed movement path without warning. Tree limbs can retain tension, compression, and leverage throughout the canopy structure. Once support fibers release, stored force can rapidly redirect branch movement. Branches under tension store energy through bending and load distribution. Structural release allows gravity and stored force to redirect the branch toward a new equilibrium position. Tree limbs can retain hidden force long before visible movement occurs. Support failure rapidly alters the branch path. Inside a convenience store, a speeding vehicle suddenly left the roadway and entered the storefront structure. Vehicle movement can extend beyond intended travel routes whenever directional control is lost. Roadways, parking areas, curbs, and building perimeters do not automatically stop vehicle momentum once the travel path changes. Inside a battery testing facility, a lithium-ion battery entered thermal runaway, while heat and chemical reactions began feeding themselves from within. Some battery fires don't depend on oxygen from the surrounding air. Once thermal runaway begins, the battery can generate enough heat and reactive gases to sustain the event internally, making conventional suppression far more difficult. Thermal runaway occurs when rising cell temperatures trigger a chain reaction between battery components. Immersion cooling works by rapidly removing heat from the battery pack, interrupting the temperature feedback loop before it spreads to neighboring cells. The challenge isn't simply extinguishing the flames. The real objective is removing heat faster than the battery can create it. Inside a rodeo arena, a bull suddenly accelerated and altered its movement path repeatedly throughout the enclosed space. Large animals generate dynamic forces through rapid changes in speed, balance, direction, and acceleration. Movement paths can change abruptly without following predictable mechanical patterns. At a truck inspection bay, a raised heavy vehicle suddenly lost stability and shifted beyond its supported position. Vehicle lifting systems depend on support geometry, load distribution, lifting point integrity, and ground stability. Small changes in support conditions can rapidly alter vehicle balance. Raising a heavy vehicle shifts its center of gravity and reduces stability margins. If support points move, fail, or become uneven, the vehicle's weight can rapidly transfer outside its base of support. Raised vehicles operate with reduced stability margins compared to ground-supported vehicles. Changes in support conditions can rapidly transfer weight outside the support footprint. In a roadside equipment lift, a crane boom carried a heavy machine over tight space when the boom structure suddenly folded under load. Confirm load weight, lift radius, ground support, boom angle, rigging configuration, and swing clearance before lifting begins. Structural loading must remain within the crane's rated operating envelope throughout the lift. Deep inside a coal mine, a transport failure releases stored cable energy through the underground track. Maintain haulage systems through routine inspection of cables, brakes, winches, and runaway protection devices. Keep tunnels clear of tensioned cable paths and moving equipment until controls are verified secure. A winch cable under load stores elastic energy like a stretched spring. If the cable snaps, that energy releases as whipping motion through the tunnel. At the same time, carts on an incline lose restraint and accelerate downhill under gravity along the rail path underground. Underground haulage needs cable integrity, braking control, and clear travel paths. Inside the busy production area, material movement suddenly enters the operating zone of an active robotic machine. Keep tools, materials, and loose items outside active machine operating areas, and use guarding, isolation procedures, and controlled handling methods during production activities. At the busy roadside work zone, public traffic and construction activities suddenly converge into the same travel path. Separate public traffic from active work zones using barriers, controlled access routes, warning systems, and clear visibility controls to prevent interaction with construction hazards. Construction areas create temporary hazards, including equipment movement, vehicle crossings, restricted sight lines, and changing work conditions. When public traffic enters the same operating space, available reaction time and safe separation distance can rapidly disappear. Traffic and construction operations must remain physically separated at all times. Inside a corridor electrical installation area, exposed conductors were being handled when an energized circuit suddenly released an arc flash. Verify zero energy before beginning. Electrical work. Never assume a circuit is de-energized. Test, isolate, lock out, and confirm voltage absence before contacting exposed conductors. In a vehicle yard, a gas cylinder suddenly lost containment and transformed stored pressure into rapid movement. Never expose gas cylinders to impact, damaged valves, heat, or uncontrolled release conditions. Do secure cylinders upright, protect valve assemblies, and handle pressurized containers with approved controls. Compressed gas cylinders contain significant stored pressure energy. Loss of containment can rapidly convert internal pressure into thrust, debris movement, and expanding gas release. Pressurized cylinders retain substantial stored energy during normal storage conditions. Containment failure rapidly converts pressure into motion. At a material processing yard, flames developed beneath a raised dump truck as heat accumulated within vehicle systems and enclosed components. Heat exposure can rapidly increase pressure within fuel, hydraulic, pneumatic, and other enclosed vehicle systems. As temperature rises, stored energy within these systems can exceed normal containment conditions. On a roof under construction, movement developed near an exposed roof edge where fall clearance conditions were limited. Roof edges create permanent fall exposure hazards wherever edge protection, restraint systems, or controlled boundaries are absent. Small changes in stability conditions can rapidly reduce available support area near elevated edges. Elevated surfaces provide only a limited support area around exposed edges. When balance conditions change beyond the available support boundary, gravity immediately transfers movement toward the lower elevation. Roof edge hazards remain active regardless of surrounding activities. Support boundaries, edge protection, and fall clearance conditions determine stability near elevated surfaces. Inside a material processing facility, a wheel loader carrying a heavy bucket experienced a center of gravity shift that initiated rollover instability. Wheel loader stability depends on load weight, bucket position, travel speed, ground conditions, and center of gravity location. Load elevation can rapidly reduce stability margins during movement. Inside an industrial production area, a rotating drum machine remained energized, while exposed moving components and active nip points remained accessible. Rotating machinery stores and transfers energy through moving surfaces, drums, shafts, rollers, and drive systems. Active motion paths remain capable of generating draw-in forces until all rotational energy has dissipated. Rotating drums create continuous nip points where converging surfaces generate draw-in force. Friction and rotational energy can rapidly accelerate material entering the moving interface. Stop, isolate, and verify zero energy before approaching moving equipment. Respect every rotating surface as an active energy source until proven otherwise. At a winter clearing site, wheel loader movement overlaps with restricted visibility and tight spacing, creating travel path exposure. Establish separated travel routes, visibility controls, reverse warning systems, and monitored crossing points before snow clearing operations begin. Machine movement should stop whenever visibility becomes uncertain. In a textile factory, counter-rotating rollers pull material inward and create a fast-moving nip point hazard. Feed textile material using guides, tools, and guarded nip points. Stop the machine, isolate energy, and correct folds or snags before production resumes. Counter-rotating textile rollers grip fabric through friction and pull it into a tight nip. When folds or snags form, tension increases suddenly and the material accelerates inward. Direct hand feeding places control too close to a force path that cannot pause instantly during active production. Textile feeding should use tools and guards, not direct access to nip points. In the material unloading area, the raised dump body appears stable until the load suddenly shifts and the truck loses balance. Stop dumping immediately. If material releases unevenly, the truck begins leaning or load movement becomes unpredictable, and reestablish stable conditions before continuing operations. On the narrow roadside recovery site, the heavy trailer suddenly shifts out of balance and the entire recovery operation changes in seconds. Verify the load path, center of gravity, recovery direction, and support conditions before lifting, and maintain exclusion zones throughout all recovery and repositioning operations. Recovery lifts continuously change force distribution as the load rotates, rises, or shifts during movement. If the center of gravity moves beyond the support footprint, stability can be lost rapidly and the load can overturn. Recovery operations depend on controlling stability before movement begins. In a mine shaft loading area, a lift gate opened beside an active hoist path as unexpected platform movement changed the clearance space instantly. Hoist systems combine suspended mass, guided movement, and confined clearances within a vertical travel path. Unexpected platform movement can rapidly eliminate available separation around access points. Along a residential garden path, a running hedge trimmer suddenly redirected its reciprocating blade path during close-range trimming. Reciprocating cutting tools generate continuous blade movement across a fixed cutting zone. Small changes in tool angle, grip stability, or workpiece resistance can rapidly alter the blade path. Hedge trimmers use high-speed reciprocating blades that continue moving instantly once the trigger is engaged. Close body positioning, unstable grip transitions, or redirected tool angles can quickly place exposed areas into the active cutting path. Powered cutting tools leave almost no reaction time once blade movement begins. Controlled grip, safe positioning, and constant blade awareness are essential during trimming work. In a processing area, a massive rotating roll remained active while an exposed draw-in path operated along the machine surface. Rotating equipment can generate significant draw-in force even at relatively low speed. Material entering the grip point between moving surfaces can be rapidly pulled into the rotating path through friction, torque, and continuous surface motion. Inside a warehouse, stability conditions changed within a loaded storage rack system, and an entire row of racks began transferring load in the same direction. Industrial storage systems rely on stability, load distribution, and structural balance. When racks are struck, climbed, shaken, or disturbed outside their design limits, the stored weight can transfer from one section to another, creating a cascading collapse. Warehouse racks carry large vertical loads while remaining relatively narrow in profile. Once one loaded section loses stability, gravity can pull adjacent sections into the same direction, producing a domino effect that spreads rapidly across multiple bays. Large storage systems can retain significant stored gravitational energy. Once rack stability is lost, load transfer can propagate rapidly through adjacent sections. Along a highway work zone, a truck entered the protected shoulder area and struck traffic control equipment, sending debris and equipment components across the roadside workspace. Highway work zones contain overlapping vehicle paths, traffic control devices, and roadside equipment within restricted space. Loss of vehicle path control can rapidly transfer energy into barriers, equipment, and adjacent roadside areas. Inside an automated manufacturing line, a robotic handling system remained active when a moving machine component suddenly swept through the operating envelope. Robotic systems store and transfer energy through programmed motion paths, actuators, drives, and automated positioning systems. Active work envelopes remain hazardous whenever machine motion and stored energy are available. Industrial robots can accelerate rapidly through programmed movement paths while carrying substantial momentum. Automated motion can traverse large portions of the operating envelope within seconds once a cycle is initiated. Robotic work envelopes remain active wherever motion paths and stored energy exist. Automated movement can continue whenever energy sources and control commands remain available. Inside a die casting bay, hydraulic platements close with immense force as guarding and isolation controls fail to secure the mold area. Keep die casting mold areas enclosed by locked gates, light curtains, and verified interlocks during every cycle. Adjustment work requires full hydraulic isolation, pressure release, and confirmation that platens cannot move unexpectedly again. In an outdoor wood processing yard, a chipper hopper draws material inward through a powerful feed path that continues under mechanical traction. Operate wood chippers with feed tools, emergency bars, and controlled exclusion zones around the hopper. Jam clearing should begin only after lockout and zero motion verification are completed. Wood chippers use feed rollers to grip branches and push them toward spinning knives. The rollers create continuous inward traction, while irregular branches can snag and pull unpredictably. Once material is engaged, the drivetrain keeps feeding until the emergency bar or shutdown stops motion fully. Chippers demand feed tools, clear stance, and lockout before jam clearing. On top of the tanker trailer during the nighttime operation, a massive vapor cloud suddenly erupts from the compartment without warning. Verify tanker contents, pressure conditions, temperature, and ventilation before opening compartments, and control all potential ignition sources during inspection or transfer operations. At the busy construction site, the concrete hopper suddenly shifts during the lift and changes the entire load path in a split second. Follow the approved lift plan, verify load weight and operating radius, and maintain exclusion zones around suspended loads throughout all crane lifting operations. As load weight or lifting radius increases, the overturning forces acting on the crane rise significantly. A sudden load shift or dynamic movement can quickly reduce the crane's stability margin and alter the lift path. Crane stability depends on controlling load weight, radius, and movement throughout the lift. Inside a pipe manufacturing line, a rotating steel pipe suddenly captured loose material within the spinning transfer path. Large rotating rollers create continuous draw-in points, where loose material can be captured and redirected into the machine path. Rotation extends the hazard beyond the immediate point of contact. Inside a forging line, a glowing hot workpiece suddenly broke loose from the hammer path and launched across the machine platform like a projectile. Forging systems combine impact force, elevated temperature, rebound energy, and unstable workpiece geometry. Small positioning changes can rapidly redirect energy beyond the intended strike path. Forging hammers release massive compressive force in milliseconds. An unstable hot metal can convert that force into sudden kinetic ejection. High temperature reduces material rigidity, while repeated impacts amplify rebound energy and unpredictable launch direction. Impact energy can rapidly redirect unsecured material. Workpiece stability and strike path control remain critical throughout forging operations. In a crowded truck yard, a dump truck lost positive restraint and began moving under its own momentum. Once a heavy vehicle begins uncontrolled movement, vehicle mass and momentum become the dominant forces governing the travel path. Even low-speed movement can rapidly increase energy within confined areas and restricted clearances. At a facility entrance, a massive sliding gate suddenly lost support within its guide and track system. Large gates store more risk than they appear to. When rollers, supports, guides, or track components fail, the gate's own weight can instantly transform a routine access point into a falling structural hazard. Sliding gates depend on continuous support from wheels, tracks, and guide assemblies. If that support is lost, gravity shifts the gate's center of mass beyond its base, causing the structure to rotate and fall with little warning. Sliding gates remain structural loads supported by tracks, guides, and wheel assemblies. Loss of support immediately transfers the structure's weight through gravity. Inside a loom factory, a hidden electrical fault energized a conductive metal component and created an unexpected current path. Electrical systems can energize conductive components whenever insulation, grounding, or circuit integrity is compromised. Conductive metal parts connected to energized circuits can become unintended current-carrying paths. On top of a large industrial storage tank, an access lid was opened when flammable vapors inside the vessel suddenly ignited at the opening. On top of a large industrial storage tank, an access lid was opened when flammable vapors inside the vessel suddenly ignited at the opening. Flammable vapors can accumulate inside enclosed tanks while remaining invisible. When vapor concentration enters the ignitable range, a small ignition source can rapidly initiate combustion and pressure expansion. Inactive appearance does not indicate a vapor-free atmosphere. Enclosed vessels can retain combustible atmospheres long after visible activity has ended. Inside an auto manufacturing cell, a robotic arm continues through its programmed motion path while the operating envelope remains active. Enter robotic manufacturing cells only after lockout, stored energy release, and verification that programmed motion cannot restart. Interlocks, barriers, and presence sensing must remain active throughout automated production without bypasses or overrides during troubleshooting. On a high-rise balcony, a wall-cutting saw bound in the masonry and suddenly redirected its force, turning a tight work area into a tool control emergency. Wall cutting at height must start with stable footing, fall restraint, clear cord routing, and firm control at both saw grip points. The blade path must stay straight, pressure must stay controlled, and cutting should stop immediately when the saw begins to bind, chatter, or pull off line. A rotating blade stores high angular energy, and when it jams in tile or masonry, that energy redirects back into the tool as kickback. Wet slurry, loose debris, and narrow balcony space reduce control margin when the saw jumps free. Cut slowly, keep the blade aligned, and stop at the first sign of binding. At height, saw kickback needs anchorage, traction, and full tool control. In the warehouse aisle, the unattended pallet jack sits across the access route until a single step suddenly turns the walkway into a hidden hazard. Store pallet jacks, carts, and material handling equipment in designated locations, and keep walkways, access routes, and aisles clear of obstructions at all times. Along the roadside embankment, the zero-turn mower enters a steep, grassy slope and suddenly loses stability near the drop-off. Follow manufacturer slope limits, assess terrain conditions before mowing, and maintain safe clearance from embankments, ditches, drop-offs, and other unstable ground features. Zero-turn mowers rely on tire traction and balanced weight distribution to remain stable during operation. As slope angle increases, weight shifts downhill, reducing traction and increasing the forces that can lead to loss of stability. Steep terrain can quickly overcome the stability limits of mowing equipment. Inside a fabrication shop, a sealed barrel suddenly erupted into a fireball during active welding operations. Sealed containers can retain flammable residue, vapor pressure, and combustible atmospheres long after visible contents disappear. Hot work introduces ignition energy capable of rapidly igniting trapped vapors. Behind a delivery truck, an unstable pallet suddenly collapsed outward as the rear doors opened. Cargo securement systems continuously absorb transport vibration, braking forces, turning loads, and shifting weight distribution. Once load balance moves beyond its support geometry, gravity rapidly redirects the material path. Shifting cargo builds unstable force against trailer walls and doors during transport, especially during braking, turning, or uneven movement. Once restraints fail or stacked pallets lean past their center of gravity, gravity rapidly converts the load into a falling mass. Vibration and repeated trailer movement can gradually loosen stacked materials, increasing side pressure against doors and weakening pallet stability during transit. Load stability changes throughout transport. Stored weight can rapidly convert into movement when support geometry changes. At a truck parking area in Tatarstan, a vehicle entered uncontrolled movement within a confined parking corridor. Vehicle momentum rapidly exceeds the restraining capability of surrounding clearances once uncontrolled movement begins. Confined spaces can transform nearby structures and parked equipment into compression hazards along the travel path. Inside a machine workshop, an exposed rotating machine created a continuous draw-in path around the moving assembly. Rotating equipment continuously transfers energy through moving surfaces, shafts, drums, rollers, and drive components. Material entering the rotation path can be rapidly captured by friction and rotational force. Rotating drums and rollers create continuous draw-in force at the nip point, where moving surfaces converge. Friction, surface speed, and rotational energy can rapidly accelerate material into the machine path once contact occurs. Rotating equipment remains hazardous wherever draw-in paths and nip points exist. Guarding, isolation, and separation from rotating motion prevent unintended energy transfer. Inside a metal processing facility, a heated circular workpiece was being shaped by a forging machine when a single strike caused the hot material to lose balance and move from its intended position. Forging operations generate impact forces that can rapidly alter the stability of heated workpieces. Load support, positioning geometry, and force transfer determine whether material remains within its intended path. On a narrow street, stacked timber planks suddenly lost load balance as one plank separated from the load. Long timber members create leverage forces throughout stacked loads. Removal of a single member can alter load distribution, support conditions, and movement paths within the remaining stack. A long plank acts as a lever, multiplying forces as it extends away from its support points. When one end is pulled free, the shifting weight can quickly overcome balance and stability. Long materials can redistribute load forces rapidly when support conditions change. Leverage and shifting weight can alter stability throughout the stack. At an urban demolition site, structural support is removed and the building suddenly transitions into an uncontrolled collapse path. Assess structural stability before demolition equipment contacts load-bearing elements. Establish collapse radius controls, dust planning, and communication signals so machinery stays outside failure paths as supports are removed safely during controlled sequencing work. At a construction lifting area, a forklift rides a crane platform, overloading equipment never designed for that task. Use crane platforms only within engineered load ratings and approved lifting plans. Dynamic vehicle loads, platform capacity, rigging arrangements, and structural limits must be verified before lifting operations begin. A crane platform is designed for rated vertical loads, not moving forklifts with shifting wheel forces. As the forklift drives, concentrated weight changes location and increases dynamic loading. If the platform or rigging lacks capacity, structural members bend, detach, or fail under the moving load. Cranes are not shortcuts for moving active forklifts without engineered certification. At the electrical panel, troubleshooting begins on energized equipment when electrical energy suddenly releases without warning. De-energize equipment, isolate all energy sources, verify zero energy conditions, and establish an electrically safe work condition before opening, testing, or servicing electrical systems whenever possible. In the tire service area, the mounted truck tire suddenly releases its stored pressure and turns the service bay into a high-energy hazard zone. Use approved inflation cages, restraint devices, and safe positioning during tire servicing, and stay outside the potential release path of pressurized wheel assemblies. Heavy truck tires contain large amounts of stored energy when inflated under pressure during service operations. If the tire, wheel component, or bead assembly fails, that energy can release instantly and rapidly propel air, force, and components outward. Pressurized tire assemblies can release stored energy instantly when containment fails. Inside a renovation area, a wall opening suddenly released unstable concrete directly into the work path. Partially demolished concrete and masonry structures contain changing load paths and reduced support capacity. Material can separate rapidly once remaining structural balance is disturbed. Outside a smoke-filled structure, a hose stream was directed at the fire when the weakened upper section suddenly gave way. Never operate beneath fire-damaged roofs, facades, or overhead structural sections during suppression operations. Do establish collapse distances and continuously monitor structural stability around active fire zones. Extreme heat weakens roofing materials, support members, and wall connections, reducing their ability to carry overhead loads. As thermal damage spreads, gravity rapidly pulls unsupported sections downward into the active suppression area. Water application can also rapidly cool certain materials, creating uneven contraction and additional stress across already weakened structural components. Combined heat exposure, shifting loads, and compromised connections increase the likelihood of sudden structural separation during active suppression operations. Fire exposure can silently compromise structures long before visible collapse signs appear. Collapse zones and structural monitoring reduce exposure to sudden overhead failures. Inside a crowded bull arena, a large animal suddenly altered its direction, balance, and movement path within the enclosed space. Large animals generate significant force through rapid changes in balance, posture, direction, and acceleration. Unlike mechanical systems, movement paths can change without fixed operating patterns or predictable motion sequences. During a crowded tractor procession, a reversing maneuver suddenly expanded the vehicle's backing path into an adjacent access route. Reversing equipment creates overlapping movement paths, restricted visibility zones, and rapidly changing clearances. In crowded environments, directional changes can quickly reduce separation distance between travel routes. Large tractors generate extensive rear blind zones and continue carrying momentum even at low reversing speeds. As travel paths overlap, available clearance can decrease faster than vehicle movement can be altered. Reversing movement rapidly changes route geometry and available clearances. Backing paths, blind zones, and overlapping travel routes require continuous separation. At a high-voltage transformer installation, energized equipment suddenly released electrical energy as an arc flash developed across the system. High-voltage systems can retain substantial electrical energy within conductors, transformers, and connected components. Electrical faults or unintended conductive paths can rapidly release energy as heat, light, and pressure. Near a roadside, a dump truck carrying a heavy load of sand traveled across uneven ground when the load and sloped surface pushed the vehicle beyond its stability limit. Loaded dump trucks experience reduced stability margins when bulk material weight combines with uneven terrain and lateral slope forces. Ground angle and load distribution directly influence rollover potential. A heavy sand load raises forces acting on a vehicle's suspension and tires. When the ground is uneven or sloped, the center of gravity shifts sideways, increasing rollover forces until stability is lost. Load weight and terrain geometry jointly determine vehicle stability. Lateral force and center of gravity shift can rapidly produce rollover conditions. On a residential utility route, a reversing service truck enters a blind rear travel path where visibility and clearance disappear. Control reversing utility trucks with spotters, cameras, alarms, and clearly assigned walking routes. Movement must stop whenever mirror contact is lost or the rear path becomes uncertain behind the vehicle during backing. Inside a cable factory, a loaded winding machine stores rotational and tension energy until a component failure releases force through the winding line. Inspect cable winding machines for tension limits, fatigue, guarding, and secure anchoring before operation. High-speed rotation should remain behind barriers, with shutdown triggered by vibration, misalignment, or abnormal noise during active winding cycles. Cable winding stores energy through rotation and material tension. If a component fatigues, misaligns, or exceeds its speed limit, that stored energy releases suddenly. Broken parts can separate from the drum, while cable tension snaps back through the surrounding machine area near the winding line. Cable winders need guarding, tension limits, and shutdown at the first abnormal sign. In the residential tree removal operation, a large tree section separates from the trunk, and the suspended load path suddenly changes in an instant. Maintain approved fall protection control cutting sequences and account for shifting weight, stored forces, and changing bucket position when removing large tree sections from elevation. In the material processing warehouse, the wheel loader raises a heavy bucket load and the machine's stability suddenly begins to disappear. Keep heavy loads low during travel, verify load weight and machine capacity, and assess ground conditions before raising buckets near equipment, structures, or work areas. As the loader raises a heavy load, its center of gravity shifts forward and upward, reducing overall machine stability. If stability limits are exceeded, the machine can pivot around its front axle and rapidly lose balance. Every raised load changes the loader's stability and operating limits. Inside a busy production line, loose hair entered the rotating path of an industrial floor fan without warning. Never allow loose hair, scarves, clothing, or unsecured materials near rotating fans, belts, rollers, or exposed moving equipment. Do secure long hair and maintain guarding or safe clearance around rotating machinery. Inside a multi-story atrium, a suspended access line suddenly lost support and dropped through the open interior space. Never rely on a single rope, anchor point, or unsupported edge during elevated maintenance access. Do verify certified anchorage, redundant fall arrest systems, and load-rated lifeline equipment before suspended work begins. Suspended access systems store continuous gravitational load and dynamic tension along ropes, anchors, and connectors. If an anchor, rope, or edge protection system fails, the entire suspended load instantly accelerates downward with increasing force. Open atrium layouts also increase total drop distance, allowing greater acceleration and higher tension shock throughout the suspended system. Without secondary attachment systems, the load path transfers instantly from controlled suspension into uncontrolled free movement across the vertical space. Elevated access work depends completely on properly rated and redundant fall protection systems. One failed connection point can turn a controlled suspension system into an uncontrolled drop path. At a construction transport site, a massive boom section shifted unexpectedly during unloading, turning a routine task into a crushing force path. Heavy equipment components do not require high speed to create hazardous movement. Once a suspended or unsecured structure changes position, gravity immediately redirects the load path and movement boundary. Inside a building service area, an overloaded freight elevator platform suddenly lost stable support while carrying cargo. A lifting platform remains under load stress until cargo weight is fully supported within system limits. Excessive loading can increase stress throughout the lifting system and reduce support stability. Freight elevators are designed around specific load ratings that determine the forces carried by cables, guide systems, and braking components. Excessive weight increases mechanical stress throughout the system, reducing its ability to maintain stable support when the platform is stopped and accessed. The lift may stop, but the load forces remain. Capacity limits exist because gravity never takes a break. Inside a commercial kitchen, a mobile rack experienced movement when a hinged equipment section suddenly released from its secured position. Mobile equipment can contain hinged sections, shelves, and movable components that depend on attachment integrity during transport. Loss of restraint can rapidly create unintended movement paths. Inside a small indoor area, gasoline vapors encountered an active pan fire and rapidly expanded into a fuel-rich combustion event. Gasoline continuously releases highly flammable vapors capable of igniting at very low energy levels. Introducing additional fuel into an active fire rapidly increases available combustion energy and flame spread. Gasoline produces highly flammable vapors that can ignite far more easily than the liquid itself. When exposed to an existing flame, the vapors combust rapidly, creating a fast-moving fireball and intense heat release. Gasoline vapor ignites far more readily than the liquid fuel itself. Additional fuel rapidly increases heat release and combustion intensity. In a crowded industrial lot, a dump truck body shifts unexpectedly and redirects stored mechanical energy through the surrounding area. Secure dump bodies with mechanical locks, pinned hinges, and verified hydraulic controls before parking or maintenance activities. Raised or unstable bodies require controlled exclusion zones until movement hazards are eliminated. On a processing plant sorting floor, an open feed hopper and loose aggregate create a sudden intake hazard. Install fixed guarding, barricades, and controlled access boundaries around active feed hoppers. Machine perimeters should remain protected whenever intake systems are operating. T-loose aggregate resting on a sloped hopper edge can suddenly shift under gravity and slide toward the intake opening. Once material movement begins, the hopper geometry funnels mass directly into the collection system. Open feed systems require permanent guarding and controlled access. Lockout procedures and physical barriers should remain in place before any adjustment occurs near active intake equipment. On the scaffold beside the building wall, the heavy HVAC unit suddenly shifts and turns the transfer into a balance problem in seconds. Use approved lifting methods for heavy equipment transfers, maintain stable work platforms, and control access between ladders, scaffolds, and elevated work areas during equipment movement. Inside a busy warehouse, a harmless-looking prank turned a wooden load into an unexpected fall path the moment the forklift began to lift. Keep all loads, pallets, and attachments clear of occupancy before forklift movement begins. Establish communication, secure the load, and confirm the lifting path remains free of unexpected weight, movement, or instability throughout the operation. A forklift transfers lifting force through the mast and forks, causing loads to tilt, rise, and shift as weight redistributes. Even a small change in load position can quickly alter stability once the center of gravity begins moving during elevation. Material handling begins with load control. Secure the load, control the lift path, and keep elevated loads free from unnecessary instability. Inside a crowded production line, an unguarded robotic arm suddenly swung across the active work area. Never enter a robotic movement path without machine guarding, interlocks, and restricted access barriers in place. Do isolate automated equipment and verify all motion systems are fully stopped before approaching the operating zone. Outside a facility wall, a tall metal scaffold suddenly leaned into an energized overhead power line as repositioning work continued near the utility corridor during setup operations. Never move, raise, or position conductive scaffolding beneath overhead electrical lines without verified clearance distances and spotter control. Do establish exclusion boundaries, use non-conductive access equipment where possible, and de-energize nearby lines before erecting tall metal structures in active work areas. Metal scaffolding conducts electricity instantly when it enters an energized line's arc or direct contact range. Electrical current can travel through the entire structure, connected components, and surrounding ground path in milliseconds, creating a massive flash energy discharge with extreme thermal and pressure energy release around the contact area. Overhead power lines must always be treated as invisible high-energy hazards during scaffold work. One small clearance mistake can energize an entire structure without warning. Beneath a lifting operation, one quiet moment ended when a suspended load suddenly dropped from above. Suspended loads remain fully dependent on lifting system integrity. Once support is lost, gravity immediately transfers the entire suspended mass along a downward load path. Beside an active roadside, exposed rotating components remained energized while an open draw-in path operated along the machine assembly. Rotating equipment generates continuous draw-in force across moving surfaces. Material entering the rotation path can be rapidly captured through friction, torque, and surface motion. Rotating shafts, rollers, and drums continuously convert motor torque into draw-in force. Once material enters the rotating path, friction and rotational energy accelerate movement toward the machine. Rotating surfaces require complete separation from exposed draw-in paths. Guarding and energy isolation prevent unintended contact with rotating motion. At a construction site, a narrow clearance between stacked wooden trusses suddenly disappeared when one stack shifted position. Stacked trusses depend on stable spacing, blocking integrity, and support geometry. Small shifts within one stack can rapidly transfer movement into adjacent materials and alter available clearances. Inside a manufacturing facility, a hydraulic press initiated a machine cycle while access to the press area remained open. Hydraulic presses generate high compressive force through controlled ram movement. Access openings within the press envelope remain hazardous whenever motion and stored energy are available. A hydraulic press converts fluid pressure into large compressive force through the movement of the ram. Once a cycle begins, stored hydraulic energy drives the ram along a fixed path, rapidly reducing available clearance inside the press envelope. As the gap closes, force increases while the available space decreases, leaving little opportunity for anything within the compression path to move out of the way. Hydraulic press systems can rapidly eliminate available clearance during a cycle. Stored hydraulic energy and ram movement determine conditions within the press envelope. Inside a partially finished construction bay, an unsecured steel pipe released from above, turning the cluttered floor into a sudden overhead load exposure. Secure overhead and stored pipe before activity continues below. Any loose, leaning, suspended, or poorly supported pipe must be restrained, lowered, or barricaded off so the drop path stays completely clear. Inside a warehouse staging aisle, a routine task was underway behind an active forklift when reversing movement turned the area into an unexpected rear travel hazard. Separate stationary tasks from forklift reverse travel paths before work begins. Establish clear work boundaries, verify rear clearance before backing, and use spotter control, barriers, or stopwork spacing whenever racks, stacked materials, or equipment structures restrict visibility. A forklift's rear counterweight swings through a wider arc than the front during turning and reversing movements. Even at low speed, the machine's mass and limited rear visibility can rapidly eliminate available clearance in the travel path. Reverse travel paths must remain clear before forklift movement begins. Separate work areas from vehicle movement zones rather than relying on visibility alone. In the concrete placement area, the suspended pump hose suddenly becomes a whipping energy path after contacting the overhead power lines. Maintain minimum approach distances from energized overhead lines and position concrete pump booms, hoses, and conductive equipment well outside electrical hazard areas during operations. In the residential driveway, the lawn tractor suddenly moves on its own as stored mechanical energy turns the machine into an uncontrolled hazard. Shut down the engine, isolate the drive system, remove the key, and secure all motion sources before performing maintenance, inspections, or equipment adjustments. Drive belts, transmissions, rotating components, and stored mechanical energy can continue influencing machine movement even when equipment appears stationary. A small control input, unintended engagement, or residual force can rapidly transfer power back into the drive system. Treat every machine as energized until all motion sources are isolated and secured. Inside a covered entryway, a ladder suddenly slipped across the smooth floor while elevated ceiling work was underway. Never, ever leave ladder stabilization unattended during elevated work, especially on smooth surfaces without secured footing or spotter control. Inside a cramped food prep station, an active grinder suddenly turned a routine adjustment into a rapid pull-in hazard. The critical mistake was assuming the grinder still allowed time for a quick adjustment mid-operation. Victims often underestimate how fast rotating feed systems can overpower instinct once movement enters the intake path. Even a brief distraction, awkward reach, or unstable hand position near exposed rotating components can instantly increase the risk of uncontrolled material capture. Rotating grinder assemblies create powerful in-running contact points that continuously pull nearby material inward. Once contact occurs inside an active feed area, the machine's rotational force can overpower reaction time almost instantly. Tight workspaces, limited clearance, and continuous motor torque also reduce the chance of safely withdrawing from the moving intake path. Active feed systems maintain continuous pull-in force during operation. Rotational energy rapidly controls the movement path after initial contact. On a road paving project, a reversing roller expanded its rear travel path within a restricted clearance work area. Heavy equipment movement paths operate with different visibility conditions, stopping distances, and travel characteristics than adjacent access routes. Overlapping paths can rapidly eliminate available separation distance. At an industrial yard, a reversing dump truck entered the same restricted travel corridor, occupied by a small transport cart. Reversing vehicles, transport carts, and restricted travel corridors can rapidly reduce available clearance when movement paths overlap. Compression hazards develop as separation distance disappears between moving and fixed objects. Dump trucks have significant rear blind spots, especially close to the vehicle. As the truck reverses, its momentum continues to close. distance creating a powerful pinch point between the truck and anything occupying the same travel corridor. The primary hazard developed from rapidly decreasing clearance within the travel corridor. Reversing operations require maintained separation and unobstructed visibility throughout the movement path. On top of a tanker trailer at night, an inspection began around an open hatch when a sudden pressure event erupted from inside the tank without warning. On top of a tanker trailer at night, an open hatch exposed the vessel atmosphere when a sudden pressure event erupted from inside the tank. Tank atmospheres can contain flammable vapors capable of creating pressure release hazards when ignition conditions develop. Vapor concentration and confinement determine the severity of pressure expansion events. Alongside a reversing trailer, a rear cargo door occupied a narrowing clearance space as vehicle movement reduced the gap to a nearby wall. Reversing vehicles and swinging structures can rapidly reduce available clearance when movement paths converge. Compression hazards develop as separation distance approaches zero. As the trailer reversed, the distance between the swinging door and the wall decreased. Even slow vehicle movement can rapidly eliminate available clearance, creating a powerful pinch point where heavy structures converge. Compression hazards emerge wherever moving structures converge with fixed objects. Clearance reduction can occur rapidly, even during low-speed vehicle movement. In a logging yard, loader movement and unsecured timber combine, sending stored force back through the trailer side. Separate logging loaders, trailers, and ground activity with clear boundaries and operator confirmation. Unstable timber, grapple movement, and trailer stakes can redirect stored force without warning during loading operations near trailer beds. In a busy loading yard, active container handling was underway when an unstable lift suddenly turned a nearby staging area into a collapse path. Place rest staging and access areas well outside lifting operations, suspended load routes, and vehicle movement lanes. A container being raised, shifted, or positioned must have a cleared exclusion area covering its full swing, drop, and rollover path before movement begins. A shipping container carries substantial weight above the ground, so any loss of balance, rigging control, or machine stability can rapidly release gravitational energy. Once movement develops offline, momentum and load mass can extend the collapse path well beyond the container's original position. Rest and staging areas must remain separate from active lifting operations. Separate suspended loads, vehicle routes, and access areas before movement begins. In the auto service bay, a routine oil change setup suddenly becomes a slip and momentum hazard as fluid reaches the walking surface. Control fluid spills immediately, maintain clean walking surfaces, and keep maintenance areas free of slip hazards that can affect movement, footing, and equipment access. On the flatbed trailer, the case loader suddenly loses stability, and machine weight takes over during the unloading operation. Verify ramp alignment, ground conditions, load stability, parking controls, and a clear travel path before loading or unloading heavy equipment from transport trailers. Heavy equipment carries significant momentum and a high center of gravity, especially during loading and unloading transitions. When traction, support, or alignment changes unexpectedly, the machine's weight can rapidly shift beyond the intended travel path. Loading stability depends on controlling alignment, traction, and machine movement at every stage. Inside a textile production floor, exposed rotating rollers suddenly turned a fabric adjustment into a dangerous entanglement path. The warning sign appeared the moment manual adjustment started happening beside moving rollers instead of after shutdown. Production environments often pressure victims into making fast corrections as near active machinery before recognizing how little recovery time rotating systems allow. At the facility entrance, the large sliding gate suddenly loses support and drops out of its intended travel path. Maintain clear separation from gate travel and fall paths, and verify supports, rollers, tracks, and retaining systems before operating, inspecting, or servicing large gates. At a rock processing plant, material became obstructed within the crusher system as the machine's feed path remained active. Material handling systems continuously transfer force through feed paths, conveyors, crushers, and processing equipment. Any material entering the operating envelope becomes subject to machine-controlled movement. Inside a workshop, a raised hydraulic platform remained dependent on support system integrity. When the lifting system suddenly failed, a raised platform is suspended energy. The moment hydraulic pressure, a component, or a support arrangement fails, gravity takes immediate control of the entire structure. Hydraulic platforms rely on cylinders, hoses, valves, and mechanical supports to hold thousands of kilograms overhead. If that load is not positively secured with independent blocking or locking devices, a single failure can release the full weight into the space below. The primary hazard was the unsupported suspended load above the workspace. Any area beneath a raised platform becomes part of the descending load path if support integrity is lost. In a production area, an operating machine maintained an active rotating mechanism and exposed compression path simultaneously. Machines that rotate, pull, compress, or feed material generate continuous motion hazards. Material entering the motion path becomes subject to machine-controlled force, compression, and movement. At a wood processing facility, a wood shredder appeared inactive when the rotating mechanism suddenly resumed its operating cycle. Machinery capable of automatic or remote startup can retain motion capability even after visible activity stops. Stored energy and automated control systems may reinitiate movement without local input. At an industrial work area, welding heat and sparks reached a metal tank containing residual vapor conditions and triggered a sudden pressure event. Enclosed vessels can retain combustible vapors long after appearing empty. Hot work energy introduced to the vessel surface can ignite vapor-air mixtures and initiate rapid pressure expansion. Even a seemingly empty tank can contain residual vapors trapped inside. When welding heat, sparks, or molten metal reach the vessel, the vapor-air mixture can ignite rapidly, creating expanding gases and a sudden pressure release. Residual vapors can remain inside enclosed vessels despite an inactive appearance. Heat and ignition sources can rapidly convert confined vapors into pressure release events. Inside a machinery area, a loose blanket entered the rotation path between two operating machines and was rapidly drawn into the equipment's moving components. Rotating equipment creates continuous draw-in paths wherever exposed moving components remain accessible. Loose materials entering the rotation path can be rapidly captured through friction and rotational force. Beside a tanker truck, a hose fitting cracks open, then trapped pressure turns the connection into a sudden release point. Don't open, loosen, or handle any pressurized line until pressure is verified at 0, the system is isolated, and the discharge path is controlled. In a warehouse loading aisle, a raised forklift load shifts the center of gravity beyond the machine's stability limits. Keep loads low during travel and raise them only when placement conditions are established. Stability limits, load charts, and center of gravity control must remain within equipment specifications. The forklift acts as a seesaw, with the front wheels as the fulcrum. Raising a heavy crate high moves the combined center of mass forward. Once this point crosses the front axle, the counterweight is no longer sufficient. The machine tips forward, dropping the load before crashing down. Stability is controlled by load position as much as load weight. Maintain a low center of gravity throughout forklift travel. At a busy construction trench, a concrete pump boom snaps overhead, sending the workspace from routine placement to sudden mechanical failure. Establish exclusion zones beneath active concrete pump booms and maintain separation from potential collapse, swing, and drop paths throughout pumping operations. Don't forget to share what you learned today in the comments. Your insight could save a life. Take care.